Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to continue writing the CSI plugin that we have been writing in some of the previous videos. And most probably this is going to be the last video in this particular series. So in this particular video, we are going to implement Node Publish Volume RPC of the Node plugin that actually mounts the volume from the staging directory to actually the directory that is being used by the pod or the container. So if you do not understand these terminologies, for example, what is node plugin, what is controller plugin, what is RPC, I have already recorded, made all these videos, and you should go and try to watch them if that's possible. Now, let's go ahead, and if we try to talk about what are all the things that we have already achieved. So we were able to write a very basic CSI plugin, and using that CSI plugin, if we try to create or provision a volume or a PVC resource in Kubernetes cluster, respective RPCs would be called from our CSI plugin, and they would do the things that they are responsible to do. For example, controller plugin is going to provision the volume, then it's going to attach the volume to the node, and then node plugin is actually going to mount that attached volume to a staging directory. And then eventually what we are going to implement today is this node publish volume RPC that is going to mount the volume from staging directory to the directory from which container is going to utilize the volume. So let's quickly go ahead and try to understand how these things fit together. So I'm just going to take an example of a node. So let's say this is the Kubernetes node that we are talking about, and in this Kubernetes node, we were already able to create a particular volume, and we were able to attach it using controller publish volume. So this is controller publish volume from controller plugin that attached this volume in this particular node. And then node plugins node stays volume RPC was actually triggered, and then it mounted this volume into this staging area. So this is the staging directory where node stays volume RPC of the node plugin actually mounted the volume. And again, if you remember, in the last video we were able to do this by running the mount command. And in this particular RPC that we are going to implement, so this RPC when called is going to mount the volume from staging directory to an eventual directory, let's say, from where container is going to utilize this volume. So we are going to call it, let's say, target directory, and we are going to use another version of mount command here to actually mount the volume from staging directory to the target directory. And that command is mount hyphen hyphen bind. So this is the command that is going to get used to mount the volume from staging directory to target directory. Now, if you do not understand why did we not actually mount this particular attached volume directly into the target directory, I have talked about that in another video. I highly recommend you should watch that out. So yeah, I think this is what I wanted to talk about, overall architecture, overall workflow. And if we go ahead and try to look into this, let's say I'm gonna say man file of mount. If you see, it clearly says that the mount command serves to attach the file system found on some device to the big file tree. And it simply means that if we look into this particular diagram, it was able to attach the file system that is found here to a particular file system. And again, we were able to, initially it was just a device, but we ran format here. If you remember, we ran format and make fs mkfs command to actually format and create a partition here. That is the reason mount was actually able to mount it to a particular file system. And in this particular video, we are going to use mount hyphen bind, and we are going to implement node publish volume here. So this RPC is going to call node publish volume, and this was node stays volume. There is this interesting Stack Overflow or StackExchange article as well about what is bind mount. I will link this down so that you can read about it. So if you look at this format, this is exactly what we have to do now. So let's go ahead and try to implement this now. So I already have a Kubernetes cluster, 3-node Kubernetes cluster up and running, and this is the source code where we have stored everything basically. And if you see here, I have just updated the secret.yaml to make sure that secret.yaml has updated DigitalOcean API key. Let's open this in our text editor. And let's increase the font size a bit. Okay, so this is what we were able to implement already. And if we go ahead and try to look into node publish volume, so if you see here, we were already able to see this particular log message in the previous video. So we were able to make sure that node stays volume is being called successfully, and after that RPC call was succeeded, this particular RPC is going to get called. So before actually implementing this RPC, let's go ahead and try to look into how request to this RPC looks like. So volume ID, as the name suggests, is the volume ID. Volume ID, publish context. Again, you should be familiar with this particular field if you have watched the previous videos. This is the field in which we have some extra information that was set from controller publish volume RPC of the controller plugin. Staging target path is the path where we mounted the volume as part of node stays volume. So if we go ahead and look into this particular diagram once again, this is the area that is called staging directory in this particular field here, staging target path. And if you talk about target path is this particular path where we actually have to mount the volume now. And once we have target path, we have volume capability. Again, volume capability is where we get the values. For example, if the request was made for let's say file system mode or block mode volumes, what is the access mode and things like that. So all those details are in volume capability. Read only, as the name suggests, is a field that specifies or using which we can figure out if the request was made for a read only volume. Secret is again another helper field, I'm gonna say. And volume context is the field that has details or extra information that were set from the create volume response or from create volume RPC. So now that we know about these fields, let's go ahead and try to try to make sure that all the required fields are already specified. So if you see here, target path should actually be required. So this is a required field, and target path is required, volume capability is also required, and then yeah, these are the and read only is also required. So let's go ahead and try to implement this. Considering the time constraint, I'm not actually going to write those conditions. Those are pretty simple. I have already implemented them for other fields in previous videos, so I think you can do that. So make sure the required fields are set and not empty. Once we have made sure that those fields are empty, what we are going to do is, if you remember, we have already implemented amount function here that runs mount -t type source and then target, and it also takes an option. So for this particular option, what we are going to specify in node stays volume is that bind thing that we talked about. And again, if you want to talk about, if you want to read more about bind, I will link this particular article in the description. You can read about it. So bind actually makes sure that one directory is actually available at somewhere else, and any changes that are made in any of those places would be reflected at other place. So what I'm going to do is, I'm going to create an array options. This is going to be slice of string, and I am going to initialize it with bind. And once we have bind, what we are going to do is, we are going to also see, if you see here, read only is also a required flag. So if request dot read only is true, in that case we are going to append RO in the mount options flag. Again, read RO stands for read only. And once we have handled read only, I think we will also have to make sure if this particular volume request was for file system mode or block mode devices. So let's go ahead and try to figure that out. And in this particular video, we are not going to see how we can handle block mode requests. We are just going to look into file system requests. So let's just go ahead and try to comment this. So get request dot volume capabilities, and make sure that you handle request for block mode as well. Here we are just handling request for file system. So you will have to, for example, see request dot volume capability, and once you got request dot volume capability, you can figure out if they have specified if the request was made for file system or block mode volume. And in that case, you will have to do separate things that we are going to talk about. So in case of block mode, we are the source is going to be the device directory where volume was attached from controller publish volume RPC. And we are going to look into, I'm going to explain this right now, so it's going to make much more sense. If you remember, when we implemented node stays volume, in that case, if the volume mode was block, in that case we did not actually do anything. So let's go ahead and try to look into that. So in node stays volume, if the volume capability and access type was block, in that case we did not do anything, because in that case we knew that we don't have to mount the volume. If I open the diagram once again, in that case we know that this particular volume that was attached here, if the volume mode is block, in that case it is not supposed to be mounted in a staging directory. That is the reason in node stays volume we do not do anything if the access type is block. But in case of node publish volume, what we are going to do is, in that case, if access type is block, the source is going to be this directory, right? Because we did not do anything in node stays volume. So source is going to be this directory, and then target is going to be this directory. So this is going to happen if if volume mode is block. But if volume mode is not blocked, in that case we know that the volume has already been staged into a directory, and then source is going to be this particular directory, and target is going to be the target directory. So let's go ahead and try to implement that. So if request.read only is set, in that case we are going to append RO into the options, and we should also try to check the FS type, because again, if you remember here, mount also takes FS type. So FS type by default is going to be ext4, and if request dot volume capability dot get mount dot fs type, if it's set is not equals to empty, in that case we are going to update the fs type with the fs type that is actually set. So now that we have fs type, all we have to do is we have to call this mount function here with the respective arguments, and we also know how do we figure out source and target. So source is going to be request dot staging target path, and target is going to be request dot target path. Let's go ahead and try to call mount for source, target, and fs type, and we also have to pass options. Once we have passed the options, if error is not equals to nil, in that case we are going to return fmt. Not really, we are going to return nil comma and fmt dot status dot error goals dot internal, and then message is going to be fmt dot sprintf error percentage s calling or mounting the volume from staging directory to target directory. Okay, and if we did not get an error, in that case we are going to return an empty response, and then error is going to be nil. Now what we have to do is, I think you know that because we have set options here in the last video, we did not actually handle the scenario if there are some options set in this particular argument. So let's go ahead and try to do that. So if length of options is greater than 0, in that case we will have to append these options into the mount args. So to do that, let's go ahead and try to look into the mount help here, and if you see, mount -- bind is actually same as -o bind. So this is what we have to do. We have to run mount -o bind, and if you look into how we can specify options, comma separated list of mount options. So we have, let's say two options, bind and read only. In that case, this is going to be mount -o bind comma ro. So let's go ahead and try to do that. So let's maybe comment somewhere, we want to run mount -t fs type, then -o bind comma ro, and then source, maybe source and target. So this is the command that we want to run eventually. So let's go ahead. If length of options is greater than 0, in that case mount args, and we are going to append hyphen o, because again if you see here it says that using hyphen o we can specify options, and all the options are going to be comma separated list of options. So to join these options using comma separated list, we are going to use strings dot join, and it takes options and then the separator using which we want to join those strings. So I think this is going to work. This should work. Let's go ahead and try to build this, and then we are going to obviously run this. So to see if things are actually working or not. But before that, let's go ahead and try to see if we have any volumes created. And if you see here, we do not have any volume in the DigitalOcean console. So go build, and we are going to, sorry, yeah, once the binary has been built, we are going to run docker build -t. Let's go ahead and figure out how are we naming these images. So 16 and then context. Once the image has been built, let's go ahead and try to push it, and then we'll have to change it in the manifest as well. Okay, so now that image has been built and pushed, we have also updated the respective manifests. Let's go ahead and try to deploy this entire plugin. So to deploy this -f manifests, and this is going to deploy everything, cluster role, so all the RBAC related resources, and then a daemon set, a deployment, service account, storage class, and a secret. And if you see here, these resources were just created. Let's also go ahead, and now I'm going to show you. To test these things, we have been creating a PVC. This PVC, if you see here, uses the storage class BSOS, and this is the storage class that specifies the provisioner that we have been writing. And then this pod actually uses or tries to use that PVC claim name test volume, and here we see the name to be test volume. So this pod tries to use that PVC that we create using pvc.yaml. So let's go ahead and try to see this. Before doing that, we are going to also look into the log of the node plugin, and let's go ahead and try to create these manifests to see what happens. So I see one pod here, it's in pending. So I'm assuming things related to controller is actually happening. Node get capabilities was called, NodePublishVolume was called, and here we go. If you see here, now task pv pod is actually in running state. It simply means that the volume has now been mounted from staging directory to the target path, from where this particular container or pod is actually able to use that volume. So yeah, I think this is what I wanted to accomplish in this entire playlist. If I try to summarize these things once again, but I will very briefly try to explain this PVC and pod. So if we look into the PVC manifest here, this PVC just says that get me 8 gigs of memory using this particular storage class. And this particular storage class, if we look into storage class manifest here, this storage class says that the provisioner here is bsos.viveksingh.dev, and this is the provisioner name that is specified in in our, or this is the provisioner name that is being returned by our CSI plugin. So if we go ahead and try to look into the driver.go, this is the default name of our uh, plugin. So now that, and after that PVC is created, we try to consume that from pod.yaml, and pod is running successfully. It simply means that volume was created successfully, and it is being utilized by the pod properly. So now that we know how things are working, let's go ahead and try to summarize these things before we actually wrap this up. So let's say I'm going to talk about a single node right now. So in this particular node, we were able to deploy, in this particular cluster, we were able to deploy a controller plugin and node plugin that are part of a CSI plugin. So once a PVC resource is created in the Kubernetes cluster, the CSI sidecar that we deploy along with our CSI plugin, they call create volume, they call they call create volume RPC of the CSI plugin, and as soon as create volume is called, the volume is provisioned in the storage provider, and then this volume is actually attached to the node using controller publish volume that we talked about, and this is actually create volume request. Once it is attached to a particular node, now there are two routes from here. If 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 this particular volume is supposed to be consumed as block device, in that case this particular volume should be attached directly to the target without being attached to a staging area. So this is the scenario in case of block mode volume, and this is going to happen in node publish volume. But if this volume is supposed to be consumed as file system mode, as a file system, in that case we are going to mount this volume in a staging directory, and from this staging directory this is going to happen using node stage volume, and then from node staging volume we are going to, or kubelet is going to call node publish volume to actually mount this volume from staging directory to the target. Now if you remember, we are handling this particular thing in node publish volume. So it's not like you have to call node publish volume twice. In node publish volume we are checking if the volume mode is block. In that case source is going to be this directory and target is going to be this directory. But if volume mode is file, in that case source is going to be staging directory and then target is going to be target directory. So I hope this makes sense. If you watch the entire playlist, I'm pretty sure that you would get a good understanding of how things are working. I would Before I wrap this up, I would highly recommend you to check this particular thing out, CSI DigitalOcean GitHub. So entire source code is basically, I would say, very much influenced or taken, copied from this particular GitHub repo. So if you want to understand something in much more detail, I highly recommend you checking this particular repo out. Apart from that, there are some other things that I would link in the description. For example, these two posts here. And yeah, I think if you see here, we were able to successfully consume a volume that is being provisioned using custom CSI plugin that we wrote. This was pretty much it that I wanted to talk about. If you think this is going to be helpful to your colleagues, classmates, share it with them. Thank you so much for watching, and I will see you in the next one.